Okay, so let's take a look here, right? This how-to. So one is understanding the concepts, and the other is how do we perform the actual procedures using these concepts. So in 3.2, my apologies, I don't have the page number here, but in the examples, take a look at all of these functions. When I take a look at this here is a polynomial function, quadratic function, radical function, radical function, radical function, radical function, cube root function, or you could say square root for 10 and 11 square root function, cube root, rational function, rational function. So there's a combination of functions, and different functions have restrictions on their domain. And so this is, where the practicing comes into play, right? So if you're only studying one type of function, you're not mastering them all. And so in this particular case, let's just kind of take a look here at number 12. 12 is a cube root. Cube root functions, and let's just say here, they're just asking us to find the domain. And they're asking us to use interval notation. So let's read that directions there. So when you take the cube root, that's our parent function. So that's where here the cube root says the domain and range includes all real numbers, right? Note that there is no problem taking a cube root of any odd integer of a negative number and resulting the output as negative. So when I look at the cube root, then I'm able to quickly indicate that the domain is negative infinity to positive infinity, in and out. And watch the clock, right? Which problems are quick, which problems are longer. However, if I take a look at problem number 18 is indicating that this is a rational function. Rational functions cannot have 0 in the denominator. So my instinct tells me to say, well, when will this denominator equal 0? Well, this comes from chapter 2. How do we solve a quadratic equation? Well, x minus 3 times x plus 2, again, equals 0, and therefore x would be 3, or x would be a negative 2. And what this illustrates here is if you were using a number line, you have open circles because they're not included, but everything's shaded here and in between and here. So what this would illustrate is that the domain is, because they want an interval notation, negative infinity, negative 2, not included, union negative 2 to 3, not included. And then I don't even remember how I could do this, so squeeze it here. And then this would be 3 to positive infinity. And these will be the possible input values. However, take a look at number 21. Number 21 is a combination of a rational, right? A rational function with a square root. So two things I'm processing. One, a rational function, the denominator cannot be 0. And 2, you cannot take square root of a negative value. So we would take the radicand, and instinctively we would set that greater than or equal to 0. However, since the denominator cannot equal 0, then we're only interested when the denominator is going to be greater than 0. And in this case, if you have negative x greater than negative 5, you're dividing both sides by a negative 1. So what happens when you divide both sides by a negative? The inequality reverses. And so any number less than 5 will work for the domain. So the domain in this particular case is negative infinity to 5 not included, and that would be the domain. And this is where the practice is going to come into play, because if you take a look at number 24, x over x, that just simplifies down to 1. So what that would illustrate is that domain here would be the same as negative infinity to positive infinity. So what I recommend, right, is, you give this a practice. I recommend that you practice the odds, because the odds you're able to check your results in the back. However, I will be providing, certain problems to turn in, but I can't collect them all, right? Because there's only one of me. So that's where it's going to require you to get, that practice needed. So first half of this section, well, it's not even a first half, it's like a third, is understanding the concept of domain and range, and being able to find the domain and range from a given function or a given equation.